Well, first of all, I want to say thanks again for everyone's time and interest in joining these sessions. This is our fourth online session, which is really exciting. So we've had one every month. If you have missed any, don't worry, we record them, obviously, and we do host them on our YouTube channel and on the Greener Space Builds website, so you can watch them at your leisure. There's been a ton of really interesting information, so I highly recommend going back into the archives if you have missed any. So I'm Anjanette Green. I'm the owner of A Greener Space Builds. Ashley's nice enough to advance the slides for me. So if you don't mind, Ashley, just a little bit about the firm that I have developed. Just in the last 6 months, I decided that I really wanted to have something that would elevate bio-based materials and support their uptick in the architecture and design community. So I founded A Greener Space Builds. It is a sister company from my consulting firm, and it is specifically for designing buildings with bio, low carbon, and mineral-based materials. There's a ton of information on the website. I don't want to waste time talking about it here. I think this is enough because I want to focus on Ashley today. But if you are interested in any of the builds that we have in the future, or if you have any questions about A Greener Space Builds, you can reach out to me. There's going to be some more slides at the end about it today. But moving along, I could not do this without the support of our partners. So I do want to give a big hats off and a thanks to the team members that have been joining us. Partners logos are up here on the screen. If you are interested in joining us as a partner, there is plenty of opportunities. Please reach out to me. We have partners that are all over the world. There is a ton of help that we need and lots that you can contribute to. And that brings me to our team and our instructors. It seems to be growing every session that we have. I am incredibly fortunate to have an amazing support team. Again, a lot of these folks are joining as instructors. You will see them on previous sessions. If you would like to hear more about what they do and their expertise, they're masters at what they have done with bio-based materials. And Ashley, you'll see on the screen, there is one of them today. So it is with great pleasure that I get to introduce Ashley Javogue. I met Ashley when I was in Costa Rica and was researching different bio-based materials on the Green Materials Tour, where I took a year off, well, almost 2 years off to travel the world and research bio-based and mineral-based materials. I felt very sincere about understanding them firsthand. So when I came to Costa Rica, I went to Zegreenlab Construction and I met Ashley, who has blown my mind with the innovation that she has come up with. She's spent the last 10 years creating one of Central America's first agro-waste to product manufacturing plants. She uses waste from everything, mainly from the sugarcane mills, but everything from pineapple stems to rice husks. There is no waste product that should be considered waste in my book. So she has manufactured these in such a way as to make blocks and panels. She's going to talk about those today. And I also had the good fortune to work with her on helping her attain the Declare label for 3 of her products. And again, we'll talk about those today. But her ambition, her entrepreneurship is just unparalleled. And I really encourage everyone to sort of approach the world through the eyes of somebody who can look at something that's considered waste and turn it into an asset. I think that's an attribute all of us could really learn from. So I couldn't be happier than to introduce and leave the floor to Ashley Javogue of Zegreenlab Construction. So take it away, Ashley.
Hello, everybody. First of all, thank you to Anjanette for organizing this, and thank you to you all for listening in. My name is Ashley, and I'm going to be presenting you today our work in implementing bio-based plantcretes, if you will, in a tropical setting. So the name of our company is Zegreenlab. It was founded in 2014, and we started, our initial mission was to promote the cannabis industry in Costa Rica. We were involved with the initial writing of the law which since has gone through several governments and several iterations. We started businesses in three areas of the application of hemp. We make a CBD oil named Osmosis, which is available in pharmacies all over the country. We have a line of hemp jeans called The Void, and we make construction products in the company called Zegreenlab Construction. Nowadays, we use mostly bagasse fibers, and I will explain that to you in the course of this presentation. We founded our company in 2014. Our original mission was to promote the cannabis industry in Costa Rica. We have three main businesses around hemp, which are a CBD oil named Osmosis and sale around pharmacies, a hemp jeans line named The Void, and the construction materials made by Zegreenlab Construction. Our facilities is based in Guanacaste, which I don't know if you heard, but it's a very particular part of Costa Rica. We have a climate that's a bit different from the rest of the country, as we have 6 months of drought and 6 months of rain, which will be the setting for the work I will show you in the course of this presentation. And our mission is to bring bio-based building materials to the mainstream. So a little bit about our beginnings with hempcrete. We wanted to build houses with hempcrete. And so to go about that, as there were at the time no hemp crops in the country, we went to Holland and visited the facility, the hemp flax facility, which is one of the biggest hemp processing facilities in the world, I think. It's in the east of Holland. The first picture on the left is a photo of my husband Emmanuel and me in a hemp crop, which is about to be harvested. This is early fall. As you can see, very tall plants, very thick stalks. We imported a container of hemp herds, and the middle photo is the container having arrived in Costa Rica, of course, had to go through all sorts of inspections, received all sorts of red lights, as the name of this material is cannabis sativa, even though it looks like sawdust and it's completely inert, has 0 THC. And the third photo is a few years later. It's a hemp crop that we managed to grow in Guanacaste in partnership with one of the big sugar mills in our area. Why would hempcrete be a good idea in Costa Rica? Well, in Europe and in North America, you use it to insulate against the cold. And so I figured that those same properties would work to keep the heat out in Costa Rica. This is a photo of our first casita that was built by me and two guys. And it was really to see what it felt like, what it is to be in a place built with hemp walls. And it turned out to be amazing. This is a house that we still have today. We use it as a guest house. There's no air conditioning. And in the hottest months, which are January, February, March, you can be inside at noon and feel very comfortable. So that gave us the confidence to say, okay, let's continue with this. So as we knew that hemp was going to be a complicated plant to work with, as it's not locally available and very difficult to import, we met two professors from the University of Lyon at a hemp building conference in Verona in 2017, organized by the International Hemp Building Association. These professors work at the ENTPE, which is the Civil Engineering and Public Works branch of the University of Lyon, Stéphane Hans and Frédéric Sallet. They work in a lab that has been studying hempcrete for decades, and they had done practically all the testing and all the protocols to really show that hempcrete is a very good material for building. And they were actually interested in experimenting with new plants. So here's sort of a variety of plants that work, the biomass from plants. The first one is abaca, which comes from a plant that is similar to the banana, bagasse, of course, which is from sugarcane. The coffee skins are sort of the skin of the of the seed, the coffee grain that is inside of the fruit, hemp herds that come from the stalk, miscanthus, which is a grass, flax, which of course comes from where you get flax seeds. Rice husks are amazing and very abundant, and nettles, sunflower stalks, and the picture is actually sort of a cottony material that is found in the stalks of the sunflower, which is very interesting for making fiber lime composites. And pineapple, the leaf of the pineapple has fibers that are very good. And this is a photo of a little plaque that we made using fiber fiber from the pineapple leaf. Sargasso is in the news these days as it's piling up on beaches and really clogging our seas. So this could be an interesting fiber to work with. It would have to go through certain tests to see how it works with lime, if it allows the lime to harden. You'd have to define how would it be harvested. Would it need to be processed in order to be usable? And generally, what would the supply chain look like for it to be a viable fiber to use in making biocretes? Here's an example of an initiative where they use tifa. Tifa is a plant that photo a thatched roof. So initiatives like that help spread the word and spread knowledge to use plants for. Okay, so how do you go from fiber to a finished wall? How do you make a wall that has a strong core and then has a protective finish, all made from the same material? Well, first, you start with the biomass. So here's a photo of a sugarcane crop in our area, Guanacaste. This is actually taken during the dry summer months. This is a crop that's close to being harvested. And it goes through the sugar mill and they squeeze all of the juices out of it. And what you get left is in the photo in the circle, which is this, what they call biomass. It's called bagasse. And it comes like this in all different sizes of fibers, from coarse to fine. Just to get an idea, this is one of the 3 big sugar mills in the Tempisque Valley region. They occupy hundreds of thousands of hectares with sugarcane. This pile of bagasse is probably a few days only. The pile can get much bigger than that. A lot of it is burnt, used in a furnace to create electricity, and there's always more left over. So it's a really abundant material. So here we sent a container full of bagasse to Lyon to be tested by the lab at the ENTPE. What does it mean to test the materials? Well, first you want to see how it acts when it's in water. What does it leach into the water? How much water does it absorb? Does it allow lime or cement to harden? And then once you found the right proportions of lime to fiber, what is the compression? What is the flexion? How insulating is it? How vapor permeable is it? What is acoustic properties? And a slew of other tests. And the goal is to make a material that is lightweight, quite porous, so you have the maximum insulation, not necessarily structural, but it has to hold up under its own weight. So that's the goal that's the kind of material you're seeking to make from these raw materials. So after all those testing, we found up with the optimal mix, and we call it Bagacrete instead of hempcrete. And then our work was to make it easy to use. So Bagacrete has characteristics that are very similar to hempcrete. The similar density, which is 350 to 500 kilos per cubic meter, and very similar compressive strength, which is quite low. And our work was to make it available in formats that could be easily used in the most widely used construction methods in Costa Rica. And then, of course, have finishes to make the walls look beautiful after that. Our first method was to make structural panels. So we would make these according to specifications of the plan. The standard size is 4 by 8 feet, but we could make them more narrow or wider, include electrical, and so when these panels arrive on site, they would be very quickly assembled. And then all you have to do would be put the finishing plaster on them. Here's a photo of a spa, a wellness center that is all made with our panels and a yellow plaster. Here's another example where you can see that once the panels have been put up in the wall, the roof can be sat on the panels because they do have that structural component. At some point, we were able to acquire a simple press, and so we could start making blocks. Our Bagablocks are quite big. They're 30 by 60 centimeters and 10 centimeters thick. So we make 10-centimeter thick walls, solid walls, and they go between columns. A word about this, the thickness of walls in Costa Rica and most tropical areas. We don't make them quite as thick as in colder climates. The idea is not to have necessarily a closed space, but rather you want to have cross ventilation, you want to be open to the surroundings, and you want to keep your walls cool to have a cool environment inside. The Bagablocks work with the most traditional materials used for a structural frame, which are wood and steel. So here's an image of a house all made in wood, quite beautiful. And the wood columns can be either offset or put flush with the panels. And then also we have a steel frame. This is very popular. Would argue that steel also has to be maintained. But here you go. This is a very common style of architecture, which is called tropical modernism. Some people don't want to have their columns visible, so we devised the Bagapanels. The panels are designed to go to the stud and track system, the same way you would install drywall or durok or other cladding systems. The panels are thicker than drywall. They're 2 inches or 5 centimeters thick, of course, because that's what the material needs to be firm. And you can put the panels either on one side of the wall or another or both. They can go interior, exterior. So for example, if you want a wood house, you could clad the outside with wood and put the panels on the inside, or vice versa, put the panels on the outside and drywall on the inside. Made to be very flexible and very easy to use. Here you have a picture of the workers. Once the panels are screwed in and you detail the joints, then you cover with a scratch coat and then this light gray color of finishing plaster. And then you get the room as you see it in the top photo. Bigger houses will have concrete columns, and so the panels work with that as well. Here's a very big house that had concrete columns, and so in between the columns you put the panels, and then we make a thinner panel that goes and covers all that concrete part. And then you detail the joints, as you can see on the upper photo, and then you cover it all with coarse plaster and you get a unified wall. The panels can also be used as ceiling panels. We make them a different size, 60 by 60 centimeters, and they can put either on top of a structure or screwed onto a structure from below. We have succeeded in making these kind of blocks, which are kind of the holy grail. These kinds of blocks are very difficult to make because the material is not as fluid as regular cement. So it's hard to get it into molds, but we tweaked a regular block mold, a very big one, a big press, and we are able to make these blocks at scale. You can make thousands of them per day. And this is a model of a production line that can be set up anywhere that there's abundance of bagasse all around this latitude of the earth, basically. So this is very promising. This is the future of our company because we will be able to sell to a much larger market. Once the walls are made, finished, you have to make them beautiful. And so we have a line of finishing plasters in different colors. And you can make them make it have different textures according to whether you trowel or float. These are very beautiful materials, and they also provide a protective cover to the walls, which is water resistant and very durable. Here are some examples. The plaster can be used on the outside or the inside, and we have different colors. And you can perhaps see in the photos that they will always have this marbled look. That's the nature of the plaster. We make it with the finer bagasse fibers and lime. We call it Bagacal. And you definitely don't want to use any paint. You need this breathable finish on these kinds of materials. It's very important because for them to have vapor permeability, they need to be able to absorb water vapor and release it, absorb humidity and release humidity. More photos. Here's a bathroom, a pink living room, and around the window you can see some rammed earth, which is quite beautiful. And outside, more of a floated kind of rough finish. A word about the kinds of structures that have been built. A lot of people come to Costa Rica wanting to live in nature. They want to have the simple life and they want to live surrounded by natural materials. So these are examples of what you would call jungle cabins or surf shacks, or this is the kind of building you can build with these materials. The top right-hand corner is actually a house made in bahareque, which is a wattle and daub in English. And people use our plasters to finish those walls, as bahareque also needs a breathable finish. Over the years, we've established a certain reputation, and now we receive orders from also luxury projects. So these are examples of this is a very big house in the south of the country, a very humid part of the country. And the right-hand side is quite a beautiful hotel in Monteverde called Hotel Del Mar. And the small photo is, well, what the wall looks like during construction. So you can see the metamorphosis of the wall from being worked on until it's finished. More examples of all sorts of houses in between. As you can see, the houses have a clean look. They don't look too messy or rustic. We can adhere to different styles. The right-hand photo on the bottom is a store where we used fibercrete plaques to decorate. This hotels, residential houses. We've done all sorts of projects over the years, and always living and learning how best to use the materials. We do get orders for decorative. Some people are interested more in the beauty of the material rather than its natural aspect or its performance as an insulator. So here you have images of finishes. The gray ones we use ash, rice husk ash, and you can either get this very marbled look either with a trowel or a float. Stencils where you have the finish and then you have openings revealing the material underneath. And also tamping with different colors of mix. That's a very popular way to work with hempcrete as a decorative material. And also luminary and furniture. Whenever we get a call asking, can you do this? We always say yes and then figure out how to do it later. It's important to talk about best practices and how to properly use these materials, as most of the time the crews will not be familiar with how to use it. And so a big part of our work is communicating that. A job site is a messy, complicated organism. And so we do a lot of follow-up to make sure that the instructions have been followed. For example, a very important thing to take into consideration is that the material should be lifted up from the ground. Groundwater is an enemy to Bagacrete or hempcrete or ramdur for that matter. So we always say that they need to put a footing on the wall, lift it up from the ground to make sure you don't get that groundwater seeping in, which the material can get wet, but it needs to breathe and really able to release the humidity. And often when it's groundwater, it's just constant water, which can cause stains and be unsightly. And another constraint is to really make sure that the material has time to cure. So for example, in the third photo, you see the panels recently installed and you see that the joints are still a little darker. There's a shadow there. So before they put the finishing plaster, which we always recommend at the end of the project, you want to make sure that's all cured and all uniform. And this sort of communication is very important, first of all, to have happy clients, but also to give contractors confidence in using the material and to make sure that they'll want to use it again. Research and education is a big part of what we do. We have with the ENTP, we made a collaboration with the TEC, which is the engineering school in Costa Rica. So we've sent students to France to work in the ENTP lab. We've also brought the professors to the TEC to make demonstrations. And the third photo is a hempcrete workshop that we organized back in 2017, I think it was. It was very popular. It was full with architects, uh, uh, builders, curious people, clients who wanted to build a house. It was lots of fun. And I wanted to give a shout out to Steve Allen, who's president of the International Hemp Building Association. And he's the man in the red shirt in the middle. And we're all dirty from having built that wall in the back. Recently, we obtained the Declare label from the Living Building Challenge. This was done with help from Anjanette, and we were sponsored by one of our clients who is seeking to get the Living Building Challenge certification for their building. We have a label for the plasters and a label for our Bagacrete materials. It's basically a nutrition label for like packages of food where it tells you what's included, what's in the material. And I mean, our materials are very simple. It's lime and fiber and water. It's all natural. It's kind of a no-brainer. But still, these sorts of labels really give validation to the material and confidence to people curious about using it. And that's all I had to say today. I wanted to end with our motto, Construyendo un mundo mejor con materiales naturales, which in English means we're building a better world with natural materials. And I just wanted to comment that animals love Bagacrete and hempcrete. We have cats in the factory, and they're always sitting on the blocks and the panels, and they love the stuff. Thank you very much.
I know that cat. I met that cat at your factory.
The factory cat.
I know that cat. Oh, it's adorable. And I knew this presentation was going to be amazing. I think that I mean, every slide could have gone on 5 different more tangents. We're
Yes.
limited with our time today. However, thank you for going through this because we do have time for Q&A. I have just a couple of housekeeping slides, but then we're going to go back to the Q&A. So we have some questions in the chat. We'll come to those. But in the meantime, I just wanted to announce a couple of great things that are happening with the Greener Space Builds project. Ways to get involved. If you have seen any of these presentations before, this should not be a new slide to you, but there's going to be some great information that have to do with the on-site learning course. So getting involved and to support the project, we have 4 different main avenues. You can come onto the job site, similar to what Ashley was talking about, where you have students come on site or just people who are interested. You have a hands-on intensive. It's all inclusive. We take care of you so you can focus on trying to work with these materials and understanding them through building. For academics or people who are really trying to research, maybe you're working on a PhD, maybe you're trying to do some studies and you really need a physical project, we have a couple of things in the pipeline that we're working on. One of them is going to have to do with our presentation that's coming up in September. But if you're in academia and you want to use our site to help with what you're working on, please let us know. We're here to help you. If you're a manufacturer, such as Ashley, and you would like to use our project site to pilot something or to help learn how do we take the project using materials that are in other regions or other climates in the world, and how do we start to bring them into the context of North America? Our project site is in Mexico, so we are not in Costa Rica. We're not in the United States either, but it's an experimentation to figure out how do these things translate across borders and regions and deal with different climates and with materials that are available to us. Our waste streams on site are going to be different than waste streams in Costa Rica, and that's part of what we would like to figure out. So if you're a manufacturer and you are working with materials and you want to figure out how do they work in different contexts, that's kind of what the Macario project is here for. And if you are somebody who would like to use the project after it's been built, as a wellness retreat, if you are interested in community events, the space is meant to be shared. It's meant to be ongoing learning for everything from people who want to experience what is it like to be inside a bio-built structure to people who would like to host some kind of event there. So please look us up if that interests you. Now for the big announcement. Um, Registration is open for our first session, and it's going to be building with bamboo. So if you happen to watch Miguel's session, which was session 2, he is our instructor for the bamboo, and he is going to be teaching us starting February 28th. That's when the first session opens. They go weekly. You can choose however many weeks you would like to come, and you can learn about bamboo all through the month of March and creeping into the very last couple of days of the month, creeping into April. So we have 5 full weeks where we're going to be building the wellness pavilion out of bamboo. Um, if you'd like to register for that, the link is on the Greener Space website. If you have questions, you can reach out to me directly. Everything you could possibly want to know is up on the website. How much does it cost? Where are we going to stay? All that kind of information. So the other part here is that we are still obviously welcoming anybody who would like to give a gift contribution. If maybe you just think this is great and you want to support, there's a way you can give a gift on the Greener Space Build's website. That funding goes a very long way to help us with this, including the scholarship program that we are promoting for people to come to learn without the cost barriers that often precludes people from learning how to use these materials. So please, a gift of any amount is very, very, very much appreciated. And then to, I think, just wrap things up, I just wanted to say that our next session is going to be September 24th. RSVP for that. The registration is open, and it's going to feature Chris Yosef and Chris Magwood, who are going to be talking about some cutting edge research that's going to be a first in the world. Again, the Macario project is a project full of surprises, and these two are going to help to develop the world's first product category rule for non-industrial materials. It's a mouthful and there's a lot to learn. I will let the two of them explain it, but it really is not to be missed. So I want to bring this back to Ashley so that we have time for the Q&A. And I did see that there were a few questions in there. Laurel, did you see any that we could maybe kick off with?
Yeah. So the first one, are your products available in the US?
Currently, no. But with the bigger factory, the idea would, rather than ship products a long way, would be to set up production lines in different parts of the world so that it's more locally available.
Yeah, and I think just I want to expand on that a little because agricultural waste is a massive problem everywhere around the world. And to think that we would ship, products that are made in one country to another, whether it's bio-based or not, is how we've arrived sort of at this big carbon mess where we're using the means of transport and that footprint it's detrimental. So think about how do we look at waste streams in our regions, and then how do we partner with the correct people who have enough information that we could set up something of a factory. Someone like Ashley has, over a decade of experience and could help walk through the process. And she and I have been talking about people that we know in Mexico who have the different presses. That press is a really integral part to making the panels. A new way of communicating with people and partnering with people. I think collaboration needs to be the way that we make this work. So I'm very hesitant to say they're not available. They're not available as far as the Zegreenlab's material, but they are available if somebody would want to be the first to experiment with making them. And I'm not even going to say in the United States. I think it's even more regional than that. If that's of interest of anyone, I would be happy to support
Yeah.
that.
Yeah, I think the production line should be close to a sugar mill, basically.
We had another question in the chat as well about if you can share any information on the embodied carbon reduction.
So we do have a number that was found by the lab at the ENTP, and I can share that. I don't have it on me right now, but yes, that can be shared.
That was my question. I actually, broadly speaking, there's hempcrete production in the US and stuff like that. And I'm always thinking about, okay, well, in terms of carbon reduction, this is great that it's bio-based, but a lot of what we do in California is kind of tracking embodied carbon, and you're still using a lime, right? Which is the big carbon footprint for concrete-based products. And to the extent that you're substituting your bio-based product for a concrete product, you still have the lime in there, so the aggregate is just different. You've got some sequestration, but I'm always curious, like how the numbers end up working out. Do you have to use less lime, or how does that?
Yeah, so to answer
The
that
numbers great.
question, yeah, so well, first of all, lime burns at I think a third of the temperature of cement, so you have much less energy being used there, and also it's a material that can be thrown back into nature. It's not going to harm, the nature. And also, contrary to like a regular cinder blocks, you want to use as little lime as possible that will still keep the material together. So the material you want it to be mostly what you see is mostly fiber and very porous, and the lime is really there to glue it together.
Yeah, it does look that way. So I was just kind of wondering, is it
Yeah.
less dense? And so then you have less material.
Yeah,
Sounds
and
like
they talk about the lime cycle, right?
Yeah.
Where you quarry the rock, you burn it to make quick lime so that you're expelling carbon dioxide, and then you get hydrated to make the calcium hydroxide, which is hydrated lime is what you use. And then the hydrated lime absorbs carbon dioxide as it cures. So I don't know if it's a closed loop, but it's close to it. Yeah, the lime carbonates rather than hydrates like cement. It needs carbon dioxide to cure.
Lime carbonates rather than hydrates. Okay.
Yeah, especially in a very aerial lime is like we use. You have different kinds of limes. You have more hydraulic limes, but we only have very aerial lime, as they would say, which is quite pure.
I need to learn about limes. Thank you.
Yeah, limes are fascinating.
It's
They
really
go well with margaritas too.
the
Oh, I
lime
had
part
another
is
question. Sorry, just really quick. I'm going to be in Costa Rica next year. Do you have any sort of public access to your
Yes, of
product?
course. If
You
you come
do?
to our area, you can find us on Google.
Uh-huh.
And yes, call me and schedule a visit. I'll be happy to
Okay.
show you.
That would be great. Thanks. I'll
Yeah.
cede my time.
Yeah, you can meet the factory cat. I would highly recommend it. It's fascinating. It was really inspiring going to see it. Um, and I was actually interested when you talked about how many other fibers you were using. I just assumed because of the name, and bagasse is a catch-all term, it just
Yeah.
means waste fiber, but I did not realize how many different fibers you were experimenting with. Um, if you were talking to someone you've done a ton of research, if you're talking to somebody who wanted to sort of make their own little homegrown mix, we had a question about corn husk silage. A lot of that is burned. What would your recommendation be for somebody who wanted to kind of experiment with different fibers and put them together? Do you need to go as far as the lab route, or is there something you could do as your own sort of on-site test?
Um, yeah, the material is not supposed to be structural, so you're not counting on that to keep the house up. It's a filler between columns. So you want to make sure that your main structure, pillar and posts, that holds up. And then there are different ways to fill up the wall. You will need a secondary structure. And then to find the best proportions of lines and fibers, it's really empirical. And if you don't have you can do it the lab route, but you can also just do it empirically. The material has to stick, not too much water, not too little, and then you let it cure and see how that feels. It should be pretty firm. I mean, it's breakable, but it should be firm. And and then you decide whether it's hard enough to fill your wall. A very interesting thing about this material is it keeps curing over time. So people have noticed that the wall just gets more and more solid over time. That's an empirical observation, but definitely something that one notices, especially with the cycles of wet and dry that helps the lime keep curing.
My question is, we have a wheat farm. Is wheat something that could be used? Once we've harvested, there's always the chaff that's left. Is that a product that could be used to make?
Is hay from wheat? No.
No, it's not hay because
Okay.
it's not grass, but it's.
I don't know specifically about wheat.
So
But you could maybe make like a straw bales. That would be a good way to use the fiber. I don't
Yeah.
know about how it would act with lime, but straw bales is another bio-based method of construction that's very interesting to explore. You actually make bales and you use those as your blocks with nothing added, maybe like a wire
okay.
structure. Yeah. Yes, so you need to have a roof over it, lift it up from the soil, and a layer of clay or lime render to protect it
I
from the
gotcha.
rain. Yeah,
Okay, thank you.
you're welcome.
I think Emily, you had a question?
I do. Thank you, Ashley, for this presentation. This was fantastic.
Thank you.
I have a question. I'm in the Midwest in the US and looking to start a natural build project. Is Bagacrete something, I don't know if you've been able to test it, is it something that could work well in areas that receive all four seasons? Sorry, I have a dog sneezing over here.
So I think hempcrete is more common in the United States at this stage. And I know that there are some people working on standards for building with hempcrete, which is great. It helps all of us to get these materials into the mainstream. And I mean, hempcrete has been used in France and England for decades now. It's a super durable material, especially when it's used properly. It's amazing. So yes, it can take all four seasons if it's used properly.
Thank you.
Welcome.
One question about codes, and perhaps you covered this, but just wondering about so the takeaway that I'm hearing is this is an incredible innovation for the space that you're in. There are waste products everywhere, agricultural waste products that could follow a similar format. When you're thinking about codes and getting these things into construction, how does that work, both where you are and as you think about this type of methodology applied broadly?
Okay, so yeah, that's a good question. So, and I mean, at this right now, the construction codes are becoming more sophisticated in Costa Rica. Up till a few years ago, I mean, we're in a seismic country. So the main thing that needs to be signed off by a civil engineer is, does the structure stand up and is it to the seismic code, which is here it's a replica of the California code and the Japan code, because we do have a lot of earthquakes. And we do get good results. When there's an earthquake, almost no buildings fall. So they're very strict about that. Now, concerning walls, because we don't have to worry about the cold, there's no coding on what goes in between that structure. And that's sort of how we've had the liberty to be able to implement it so easily here. Whether it's use glass or drywall or anything, that's not really a concern as far as coding goes in Costa Rica. That's slowly changing as the buildings get more sophisticated, but and we're following that along so that we can, keep on that train. And I know that in the United States and a lot of other more developed countries, you have much more strict coding. And so I think it's hemp texture. Some people are working on a ASTM. I can't remember the number of it. There's a working group, and they're pushing hempcrete. I'm not talking about hempcrete because it's very interchangeable with Bagacrete. It's all about what part of the world you are in, right? What kind of fibers you would use. And so the two characteristics that they are promoting would be the fire resistance, because incredibly enough, it's very high fire resistance, and the insulating properties. And that's those are the things you would take into account in using this material in a building in the United States, for example. I hope that answers your question.
Yes, thank you.
Okay, you're welcome.
Yeah, I think it's worth, there's a resource, the Bio-Based Materials Collaborative. If anybody is not already involved or going to their meetings, that group is incredibly advanced when it comes to getting these materials into code. They have an entire team dedicated just to helping getting code and acceptance. Code gets really messy really quickly with bio-based materials because the United States in particular is a patchwork quilt of code and how it's adopted. There's the federal level, and then there's every state has a level, and then there's residential versus commercial. So it gets really complicated really quickly. But there are some states that do better with bio-based materials than others. New Mexico comes to mind because, again, it's really a very arid climate. But if you're not on a group of grassroots involved concerned citizens, a lot of these groups will meet and the code will either be rejected because it didn't have enough support from people talking about it, or they will just phase it out. So you really have to stay on top of these organizations. And if you ever have a chance to try to attend one of the meetings where they talk about it, they are open to the public. So things like ICC, the International Code Council, if you have a chance in your community to try to get to one of these meetings or at least get on their mailer list, it does help the more people attend and get involved. They don't just happen on their own. They happen because people are trying to promote to get them into the building code. I think we have some links here that talk about how you can join the different groups. If we could put one, last time I checked, the LinkedIn for the Bio-Based Materials Collaborative was invite only. So maybe we can put that up there. Great group, definitely worth looking into. Again, I do want to say thank you to Ashley. I appreciate your time. And also for anybody who is either dealing with fires or fire regions or smoke from fires or earthquakes or anything, please take care. Everybody look out for one another. We need bio-based materials now more than ever. We need to advance this quickly. So I appreciate everybody signing on to try to get this up into more buildings and work together to get them built. I'm gonna just quickly share my screen for a second with the information for the sign up information for the Build with Bamboo. So if you're interested and you want to be part of the group, we do have a limited amount of people. The space is small on purpose because we can't have too many people on the land because it is a really precious piece of jungle. And we also want to make sure that everybody has a really great experience with really intense one-on-one training. So if you're interested, please make sure that you go to the Greener Space Builds website. All the information, including where we will be staying, which is a petite hotel in La Valeta in Tulum. We'll feed you, we'll take care of you, we'll have all the amenities that you would want, including a room to yourself. I'm not going to put you in bunk beds. We're going to have free time. Your weekends are yours to explore the region. So please take a moment to look at it. All the pricing, FAQs, everything is available. We would love to have a really great group of people who want to learn. So don't hesitate if you have questions to reach out.
Thank you so much, Anjanette and Ashley and everybody for jumping on the call today.
Thank you.
It's awesome to hear about. Thanks.
Thank you.